So what we're going to go over is this question. We started going over this in school and we talked about it in depth. What we decided to do was to substitute in the relevant values. 55 equals a times 2 to the power of 0 plus 10. We then solved this equation and we worked out a to be 45. If you're not sure about this, please let me know. We're then going to go to the calculator. And for question B, it says find the time in years for the population to decrease to 20 turtles. So initially we typed it in the calculator like this, but this is the incorrect way of typing it in. And this is because we want the power, which is going to be minus t, or using the calculator minus x, to be in brackets. So let's clear this and type it in. So we know that a is 45, so 45 times 2 to the power of, now this is when you put the brackets in, so if we're ever doing the power of negative, we're going to put brackets in, minus x in this instance, which is going to be our t variable in this function, plus 10. And we can see the model now. So this is going to be the time, and the y-axis is going to be the populations of the turtles. So you can see it stagnates around this point. But the question we want to answer exactly is find the time in years for the population to decrease to 20 turtles. So if it's decreasing to 20 turtles, we're going to have a line at y equals 20. So on y2, we're going to say y2 equals 20. And we're going to click graph. Now the intersection of both the red and the blue will tell us the number of years exactly where these intersect. I'm going to zoom in a little bit more for this because actually we need a smaller x-min, and we need a smaller y-min as well because we've now shifted the graph up by 10. So press graph again, and we want to find the intersection between these two, the red and the blue, and that will give us the exact time in years rather than guessing at the time using the table method. So we are going to press for this a calculation, and the calculation we want to press is above the trace, so second trace. Then we're going to press 5, which is the intersect. We need to select the first curve, which is here, so we're going to press enter. The second curve, make sure you're not on the intersection yet, and then we're going to go for the intersection, which is roughly here. So the intersection happens at 2.1699925 and y equals 20. So we're at 20 turtles. This happens after 2.1699 years. This is how you answer question 1b correctly. Question C. There is a number m beyond which the turtle population will not decrease. Find the value of m. And this is when we get the repetitive pattern. There we go. When we get to 10, it does not change. It just stays at 10. And this is because the asymptote of our exponential function is going to be 10. So the number m beyond which the turtle population will not decrease is simply going to be 10. You didn't even need to look at your table, and the reason why is because this is the asymptote of the exponential graph. Let's go on to the next question. The next question says the amount of years that g grams in a sugar solution can be modelled by the function like this, where t is the time in minutes. The initial amount of yeast in the solution is 2 grams. So it's going to say that this y-intercept is 2 grams. So we know that gt, the function, is going to be 2. So find the value of k. This is very similar to the previous question. So the first thing we're going to do is we're going to take this function and we're going to solve for k or c or t. We're going to talk about which one we need to solve for specifically. So we know gt is going to be 2. This is because it's the initial starting phase. At the initial starting phase, we also know that the function itself, which is to do with t, is going to be 0. So 2 equals 10 minus k, another unknown variable, which is c to the power of minus 0. And we know that anything to the power of 0 just becomes 1. So this here is just going to be 1, so we can cancel it off. So then our equation becomes 2 equals 10 minus k. We need to solve this equation and we will get k, because we're going to move k to the other side, equals 8. This is the easiest possible way you could do this question. So for part B, we're going to substitute k equals 8. Section B, the amount of yeast in the solution after 3 minutes is 9 grams. Find the value of C. Now we need to substitute in the time, which is t. We need to substitute in the gt function, which is going to be y. And we also need to substitute in k, which we just calculated. And we calculated that k was going to be 8. So if we get the function, and we're going to copy the function, and we're going to move it down here, and we're just going to substitute in the relevant things. So the first thing we're going to do is we're going to substitute in g of t. G of t in this instance is going to be the weight, because we can tell that this y-axis is going to be the weight. 9 equals 10 minus 8 times by c. C is what we believe we have to calculate, to the power of time, 3 minutes, minus 3. Now there's a couple of ways we could do this problem. Now I've written it down, I think the easiest thing is to put it into the calculator. So we're going to go into the y equals, we're going to type it in, 10 minus 8. Before we do it, we're going to clear the function. 10 minus 8 brackets c to the power of minus 3. So we're going to type x, and I'm going to put a double bracket here because we're doing it to the power of minus 3, and we need to double close the brackets there. We probably could have done without these outside brackets, but it's worth putting them in because we want to do minus 8 times everything inside here. We're now going to perhaps graph it to see if it looks okay. It does indeed look like an okay exponential graph. And we're going to have a look at the table. So in the table, we want to work out when we have y equal to 9, therefore what's our unknown. So you can see 9 is tending to the asymptote, which is 10, but when does it actually become 9? So go onto the left hand side, scroll up, and keep scrolling up until you find 9. Very simple. It becomes 9 when c is 2. So c is going to be 2. The algebraic way of doing this would be to solve this equation with paper. So 9 equals 10 minus 8 to the power, 8 times c to the power of minus 3. Now we've got to think of a way of writing c to the power of minus 3. A different way of writing this would be the following. If I copy all of this text, anything which has got a negative power, we can change it into a fraction. So this would be 1 divided by c to the power of 3. Now we have to make c the subject of the formula. The way we're going to do that is expanding the brackets. 9 equals 10 minus 8, because we're going to do 8 times 1 divided by c to the power of 3. And actually, for this question, I think it'll be better if I actually draw on the screen so you understand exactly what I mean. So if we take this, 9 equals 10 minus 8 lots of 1 over c cubed. So effectively, what we're doing is we're multiplying two fractions together, 8 over 1 and c over 3. And when you multiply them together, the 8 becomes the new numerator and the c cubed becomes the new numerator. So we get 9 equals 10 minus 8 over c cubed. We're then going to take the c cubed and the 8 over c cubed onto the other side because we want to make c positive. So it becomes 8 over c cubed equals, and then we're going to take the 9 to the other side, so that becomes -9, so that becomes 1. Now we need to rearrange things. C is on the denominator, we don't want it there, so we're going to times both sides by c cubed, and then it becomes on the numerator of the right hand side. So we have 8 equals c cubed. And then we need to find the cube root of 8, which is what number goes into 8 3 times to give 8, and we are going to have 2. Technically, you will have two answers. You'll have +2 and you will have -2. Let's have a look at the mark scheme to see if this is correct. So what we can see from the mark scheme, the answer is indeed c is equal to 2. And the reason why, if we have a look at the graph, you can see this exponential function takes two parts. However, because this is to do with a population model, we know that x must be positive here. So we want to focus on this right-hand side of the graph. And if we're focusing on the right-hand side of the graph, what we need to make sure is that we are just focusing on the positive value of c. Let's go over the last part, which is going to be 2c. So looking at 2c, it says write down the maximum amount of yeast in this solution. So let's have a look and remind ourselves what's going on here. So it said the amount of yeast, g grams, is a sugar solution. So the maximum amount of yeast is going to be the asymptote. So we need to work out what this dotted line is. You can either just look at the function and read it's 10, or you could go to the calculator as before. And using the calculator, we can see that using the table, the maximum number it goes towards is going to be 10, and it will eventually reach 10, as you can see. Now let's have a look at the final part. What I'd like you to have a go at now is question 3A, B and C. This should take you 6 minutes or so. Off you go.